Okay, the situation that we're going to have is a normal distribution. And we talk about it is going to be the case that x, the variable, is going to be a continuous one. Basically, what is going to be happen, this is the instruction for the normal distribution case. You see, the normal distribution is going to be a distribution that the formula is a little bit complicated, but we just considering the graph of the normal distribution, which is this graph. So if you know, if this is going to be the x-axis, if you have some numbers on the y-axis, you find the point, you connect them together, that gives the graph. So if I give you the result of the test, okay, so the distribution of your grade is going to be this one. We call it normal distribution. It's very easy to identify because they are going to be tell you that this is a normal distribution. So the variable x, for example, your grade, your weight, your height, your salary, all of them are going to be normally distributed. So as soon as they say normal distribution, you have to look for two numbers, the mean, population mean, and the standard deviation. These two numbers would be given to you. So three terms, normal, mean, standard deviation. That would be the first paragraph of the problem from now on. Then there is going to be a probability question. That probability question is going to be probability that x to be, for example, x could be less than 2, bigger than 2, between 2 and 3. So what we're going to do is you have to change your variable x into the z, because the z is the standard variable that we're going to use. So the z would be x minus mu over sigma that we did it before. So whatever question is given to you in terms of the x, you change it into the same question in terms of the z. So if this is the fact that the probability to be less than 2, z would be less than 2. Okay, then your question would have three possibilities. Probability of at most, if you like, less than. So less than, we talk about it, the area and the normal curve correspond to the probability. So this is going to be your z curve. When it's a less, you identify these numbers, it's going to be the area to the left of the z. If you find the area to the left of the z and change it to percent, that would be the probability that z is less than a. If it's going to be greater than a, it's going to be greater than a, so you have to pick the area to the right of your, okay, your curve. But since the table would give you only the area to the left, you have to find the complement. So if it's the right, you find whatever percentage is it, then you find the complement. And the third case is going to be between two numbers. If it's going to be two numbers, you identify the numbers. Your curve is going to be something in between. So you find the z value, z curve for the a, everything to the left of the a, everything to the left of the b, and you get the result. And remember, they are like interval. When we say z is less than a, you see on the number line in algebra, you go from negative infinity to positive infinity. So less than a would be from negative infinity to a. This would be a and positive infinity. And that gives you the, the natural interval that we're going to have. Okay, so I gave you one example the other day. I'm going to explain it again. Example was, about the number of the pounds of the newspaper that we're going to waste it or recycle. That was the situation that we have. This procedure is normally distributed. The mean and the standard deviation was given, and we usually pick one person out, in this case one household, and we check if what is the chance that in your household you are wasting 30.2 pounds of the newspaper every month, or more than 32.5. Okay, so what you're going to do as we talk about it, you change it to the z score. That give you 1.1. Then the same question would be the same as the problem for the z. So p of z to be bigger 0.1. So you have to graph it. All the problems you have to give us the graph. So there's going to be 1.1, it's going to be 1.1 up. So we gave you the table. Okay, if you want to use the table, it's not bad. So you have to have a copy of this z curve that I posted for you. In this table, the z number is going to be on the first column, and the percentage or the probability is here. So if you want to find the 1.1, so this is going to be z of the 1.1. If you are going to have a second decimals, so you go forward to get the second decimals. So it's going to be 1.10, this is the one, 1.11, 1.12, etc. So in this case, we were looking for the 1.1, so 86.43 was the answer. Yes, 86.43. But that with the area to the left, you have to find the complement. So we arrive at the 0.1367 or 13.57% was the final answer. Okay, any question? Now, if you like, you can do it with your calculator. I accept it, but you have to give us this curve. Okay, you have to identify the curve. That's good for you to see if it's direction to the right, to the left. Okay, so for example, if you want to do it with your calculator, you have to consider these intervals. You see, this is 30.2 is 30.2 and positive infinity. The way you're going to do it, you go to your calculator. Okay, this is going to be the one. The distribution is here. Okay, that's a variable, and on the second you will see the distribution. So you click the second, then the distribution. You will see all sorts of distribution that we're going to use in this course. You see the first one is normal distribution. For the normal, you have two choices, the normal PDF, the normal CDF. For this type of problems, you are going to use that CDF. So you go down, you click on number 2, okay, or just this one. If you click on number 2, that gives you this result. Look at this one. Lower and the upper is going to be the interval that we're going to use for these problems. For the infinity, we use EEE99. In this, if you use TIT 83, 84, that's already there. Otherwise, you can type it yourself. So you put the lower and the upper. You see in this case, look at this one. You are interested finding the probability that X to be bigger than 30.2. So the lower number is 30.2, upper number is infinity. Okay, so this is the way you are going to do it. So for the lower one, I just put the lower one here. Okay, let's just go ahead. Let's just clear this one, and I come back again. Okay, let's see if I go back, then I come back again. So that's second. Okay, that's the second. You click here, then you go to the normal CDF. That's a normal CDF. So that gives you the lower. You see this E99 is just infinity, negative infinity. If you don't have any lower number, you just leave this one. But in this case, you have the lower number. So you are going to use your lower numbers. You put the clear, and the lower number is 30.2. That's a lower one. Okay, so for the upper one, we don't have anything. So you go to this is going to be this one. Okay, so the upper one, I'm going to use double E one. Yes, this is a double E. Okay, the second I double. I should get this one. Okay, so that's going to be 1. It's going to be a double E that gives us that infinity. Where is the double E? Yes, the double E is here. So if you put the second, that should give E. Just try it. So I go to the mu. Mu for this case was 28. Okay, so this is going to be 28 that I have. Then I go to the sigma. My sigma is 2. So the sigma would be 2. Then you move it down to paste it, and then I missed this one because I didn't do it again because I didn't have that 30.2. Just try again. So I try this one. Let me try again. I'll come back to it again because I have a difficulty getting that number. You see, this is another version that I have. In this version, I go to the second, I go to the statistic. Okay, this is the statistic, so I go to the distribution. You see the distribution, I can see the normal distribution, number one. I go to the two, in that CF. You see, that is, you start with the, okay, you start with the mean. The mean is 28, that's a 28. Then you go to the sigma. Sigma is equal to the 2. You go down, you see the lower and the upper. In this case, the lower number is 30.2. The upper number is forever, infinity. So you just click on this, calculate. You see the number? 0.1356. And this is the number. 30.57% or 0.1356. Okay, so it can be done with the calculator, and it's going to be very easy. The other one I'm going to modify it and show you. So that's one option. You have both options on the test. We don't mind, but if you learn this one, that would be fine if you have the calculator. If you don't have it, we don't mind. So we just do it as we did it here. Okay, you have to change it to the Z, and then come back, we get 34.5% that we have here. Okay, any question? The second one, you see the second part, they ask you to find the probability that the number of the bonds going to be between 27 and 37. So what we do, if you want to do it without calculator, you have to find the X1. You see, you find the Z numbers correspond to these two. So that the -0.7 and 1.5. So you go to the table and you check the Z number for these two. For 1.5, the Z number is going to be 0.9332, and you subtract it. So that gives 62.47%. Again, if you want to use your calculator, so for this one, I go to the second and I find the distribution. For the distribution, I get to the normal. Okay, so that was takes a little bit of time, to practice to get these numbers. So I go to the second. That is the second, that's the distribution. Okay, I'll go to the number 2, which is CDF for the normal. That's the number 2. So my mean is the same one. Okay, and the standard deviation. So I go down to you see the lower and the upper. In this case, the lower bound is 27. That's a 27. Okay, that is the lower bound, and the upper bound was 31. 31. So you go and calculate. You see, if you calculate, the result is what? 62.46. So that is 62.46 or 47. And you can do it with TI-84 and all right away. So it's good to learn that, if you have this is a cheaper calculator. Okay, that's one. It will do everything the way that you can do with the TI-84. I think something like $30 on Amazon. On the other one, if you have a TI. But anyway, if you don't have it, we don't mind. And you can use the operations. But if you want to do it on the test, you have to write this expressions over here, get the curve, and give us the final answer. Okay, I do both of them when I do all the problems for you. So we don't mind the operations manually or just using the calculator. Okay, any question? So this is how we're going to operate for our result from now on. I quickly give you another one. Just make sure that everybody is happy about this one. And we give you 1 or 2 questions on the test on the next quiz that we're going to have. Okay, let's get one more. to make sure that we are familiar with what we are doing. Any question? So this example, I give you a quick one. Again, both methods. And then there is another problem that we have to tackle. So let's have another example. This example is of this format. It's a normal distribution about the soda, the volumes of a soda. Okay, so the volumes of soda in quarter of soda in volume in quarter bottles are normally distributed. So the X is the volume normally distributed. So they should give you two numbers. What is the mean? With a mean, okay, with a mean of, what is mean? 32.3 ounces. Okay, and a standard deviation. Standard deviation. The standard deviation of 1.2 ounces. Okay, so that's the situation we're going to have. You see, you have the normal term, you see, normally distributed. You look for the mean, this is the mean, and you look for the standard deviation. It's always the case. You have to identify these three quantities for yourself. Now the question is going to be, they are going to pick one out and ask the question. So what is the probability? What is the probability that the volume of the volume of soda in a randomly selected bottle, in a randomly selected bottle, one bottle will be, okay, will be less than what? 32 ounces. So that's a question. Are you ready? Change it to the symbolic form. Solution. It's a normal case with the, okay, just for your information, it is a normal distribution. Normal distribution with, you quickly identify the mean. Mean is given to you, mu is equal to the 32.3 ounces, and the sigma is given to you is equal to the 1.2. You write the question in symbolic form. You want to find the probability that the weight is going to be, volume is going to be less than 32. So the question is, what is the probability that X is less than 32? So that's the question. The calculator will do it right away for you, but I do the operations and then I check it with the calculator. It'll be accepted on the test if you want to do the calculator. Okay, so you have to find the z-score. So you find the z-score. So X is equal to the 32. The z-score for the X is going to be X minus mu over sigma. Substitute 32 minus mu of 32.3 divided by the sigma of 1.2. You subtract it. Make sure you get the, okay, get the sign all right. That's it. So this is going to be negative. On the top, it's going to be negative 0.3 over 1.2. Simplify it. You can drop the decimals if you like, so that give you 3/12. Okay, it's going to be a quarter, which is going to be 0.25. Okay, so this is going to be negative 0.25 or a quarter. Remember the z numbers, so you need it with the 2 decimal places. So the z-score is going to be negative 0.25. That was a 32.3, so that was a bigger number. So that's going to be a negative number. Any question? So the same question now would be changed into the z. We're interested in p of x less than 32. So the question is going to be p of z less than negative 0.25. So if you get the curve is the area to the left, and one reading from the table will give you the result right away. Okay. So that give you a better understanding to get the table, to get the curve. Otherwise, you can do it right away. So that's, for example, it's going to be negative 225. Since the less than 1, so the area to the left. So the reading from the table, z equal to the negative 0.25. You see that's going to be your z, or the negative 0.2025. So you have to go with a 0.2 first. Okay, that's going to be negative 0.2, negative 0.25. So this is 0, 0, 1, 2, 3, 4, 5. So it's going to be 0.40. Okay, 13. 0.40. Okay, so negative 20, 25. But double check it. Yes, it's going to be 0.40. So that would be 0.4. Okay, so that was the one. 0.4013. I made notes. I made a mistake on that one. So which is going to be 40.13%. So the probability that the volume of the soda is going to be less than 32 ounces is going to be equal to the 40.13%. Any question? Now, if you want to do it with the calculator, we don't mind if you can do it. So for the calculator, you need this information. You see, you want the probability that x to be less than 32, with the information that the mu is equal to the 32.3 and the sigma of 1.2. So this is like, this is like a negative infinity and the 32. This is your interval. Those double E that you see on the calculator, that would be the infinity. So if you go to this one, or just your TIs, so I go to the second, I get the distribution. That's the distribution. Then I go down to the number 2, normal CDF. Okay, normal CDF. So quickly they ask for the mean. The mean is the 32. Okay, mean is 32.3. 32.3. Then the second one is the standard deviations of 1.1. So that would be 1.2. 1.2. Okay, then you go down. They ask for the lower and the upper. You see, the lower is a negative infinity. That negative 1E99. This means negative infinity on your calculator. Okay, negative 1E99. You can type it if it's not. Negative 1E99 is a negative infinity. And the upper one is, okay, the upper one is 32. So you have to clear this one and get the 32. Okay, so we want to now find the probability that is going to be p less than 32 or negative infinity is the interval. negative infinity 32. So we calculate, that is going to be the number 0.40129. If you round it, that gives you 0.4013, which is the same number that we get over here. Okay, 40 point, that is the case. 40.129, we rounded into these numbers. Okay, so we don't mind. If we can do it, we don't mind. So the probability x less than 32 is going to be the same thing, 40.13%. Any question? So pick the method whichever you are comfortable to do it on the test. You know, some people like technology, you can do it, but always you see this is also the case. You can use the table and do it. Okay, any question? So that's going to be our first problem. We are going to give a couple of problems on the normal distribution. As I did it the other day, we give you one problem to read these numbers for us. You can read it from the table or the calculator, you know, the area to the right, area to the left. You will see I post your practice quiz, then you will see it for the next quiz that we're going to have. Okay, now there is another very interesting problem of the normal distribution. It's a kind of converse problem. You see in these problems, the x was given to you, then you find the probability, you find the z if you like. You see the z was given to you, you find the probability or percentage. Now when we apply this method in everyday life and for the rest of the course, we have to do it the other way around. So sometimes this probability will be given to you, then you want to find the z. We call it the converse problem. And the method is quite interesting, and as we go on from now on, we use it in different format, different version. The version that I'm going to explain it for you is, in your book, they give you some abstract problem. You see, you're not interested, just abstract problem. Would like to make a situation and then get the problem. The situation is going to be in everyday life. You see, as soon as you go to Best Buy and you buy something, they offer you something at the end. They say, oh, do you want to buy a guarantee on this one or warranty? You see, but when you look into in your product, if you like, the one that you have, you know, iPhone, Ion, etc., you will see that they write, you know, the warranty time is 2 years, 4 years. We want to know how they are going to set up these 4 years. Okay, if it's going to be 4 years and you know you get a cell phone and tomorrow there's something wrong with your cell phone, you are going to take it to Best Buy or you know Verizon, etc., and they are going to replace it for you. So the problem is how they set up that 4 years. Okay, or if you order a Pizza Hut, for example, if you order it, they usually say we are going to deliver it in 30 minutes, otherwise it's free. How you set up that 30 minutes, okay, then you are sure that you are going to make it. They are all normal distribution. Okay, so there are a kind of 2 types of problems. I'll give you 2 examples. It's not a difficult problem, but to identify which one is it, the first type or the second type, would be quite interesting. Okay, and then we're done. There is again one part that you can use calculator or you can use table. I'll give you both of them. Okay, are you ready? Any questions so far? So this is a straightforward because all the information would be given. You know, it's a normal distribution. So let's do the everyday life problems. Okay, I'm going to give you 2 examples, or maybe 3. So let's start with this first one. Is a kind that you have quite a lot in your book. Okay, so this is a kind of converse problem. If you like, I can give you, and this is going to be like, you know, let me write something for you so you know if you want to use it for a problem of your book. We would like to find, okay, sometimes we want to find the data value, which is going to be i.e. x. Okay, data value x with the given a specific probability. specific probability. Okay, probability. Probability is probability is going to be like 1%. So this example would be related to this type of ideas. Okay, so let's have the first one. The first example is sometimes if you want to be higher, you'll be given a test. Then there is a minimum score that you have to get in order to get to that, to that training, if you like. So this is it. To qualify, suppose you apply for the police academy, this is the problem. To qualify for a police academy, police academy, one must score in the top 10%, in the top 10% on a test that they call a training test or general ability test, on a general abilities collection of tests, abilities test. Okay, so you are going to be accepted or will qualify if you are going to be, your grade is going to be on the top 10%. So we want to know what's the minimum score that you have to get to be to that in the top 10%. The thing that we know that if X is going to be the scores, these scores are normally distributed. So the test, I'm going to give you this information. Of course, the test has a mean. Okay, has a mean of 200, and a standard deviation, and a standard deviation, a standard deviation of 20. Okay, so these are the information we talk about it as soon as they say it's a normal distributed and is, let's say, and is normally distributed. Normally distributed. I mean, the score is going to be normally distributed. Okay, so the score of the test is going to be normally distributed, and the mean of the scores is going to be 200, and the standard deviation would be 20. So what's the question? The question is, what is the lowest possible score that you have to get? So find the lowest, the base. Find the lowest possible score to qualify. Okay, to qualify for the training. See, as you can see, the percent is given. The percent you can consider as a probability. Okay, consider as a probability. So the situation that we're going to have, you see, it's a normal distribution again. So you note that the case is normal. So it is a normal distribution. It is a normal distribution. So when we say normal distribution, you have to identify those numbers. Okay, with, you identify your mean. The mean is given to, the mean of the test is 200. Okay, and the standard deviation of the test, sigma, is equal to 20. So previously X was given to you, find the probability of X, but this is the other way around. Okay, let's get a graph to see what does it mean. You see the situation is going to be this one this time. This is going to be your normal curve. Okay, this is going to be your normal curve. This is going to be the scores. It's going to be the scores. Then you are going to be accepted if you are going to be in the top 10%. So the top 10% means you got to be in the top 10% of this graph, if you like, area. So if you consider this is going to be the top 10%, you see, this is going to be the top 10%. So this area is going to be 10%. So if you are going to be in this top 10%, you are the winner. You are going to be accepted. So what they ask you, this is this is it. They ask you for the lowest point. So the lowest point is going to be the number that you're going to pick. You are going to find here. So you have to find an x, if you like. Let's call it x0, for example, a number. So x0 is going to be your score, or x is going to be your score. So from the probability point of view, this means, you see, this means you should find a number. Okay, find a number, let's say x0, such that what? You are going to be in this area. You know that this area to the right. So this means you are going to be in what? Probability that x to be greater than x0 is equal to the 10%. See, that's your problem. So it's like probability is already given to you. You know, probability is already given to you. Then you want to find that number x. Okay? So you know that, so order, we usually work with the z because we want to get it from that table. What you are going to do, if you translate it to the z, is going to be like, you are going to find a z number so that p of z to be bigger than the z naught to be equal to the 10%. Okay, 10%. So this is going to be the same thing. It's going to be the same curve. I just change it to the z. So you need the z naught here so that this area to the right of the z naught to be equal to what? Equal to the 10%. And you want to use your table. Okay, but you know that the table or the calculator, doesn't matter. The table would give you what? When using the table give you area to the left, not the area to the right. So if the area to the right is going to be 10%, so what's going to be the area to the left here? Any suggestion? Remember the total area under the z curve? The total area under the z curve is 100%. So if this is going to be the 10%, so the leftover would be, would be 90%. Okay. So the leftover is going to be, would be 90%. So the problem is going to be, you see, this is going to be the one. So this area is going to be 90%. That's a crucial part of the problem. Most of the people, they pick that 10%. That's why I ask you to graph it. So if you want to use your table, okay, the table only, the z number give you area to the left only. So this 10% is not the area to the left. 10% is the area to the right. So the area to the left would be 90%. So now this means what? This means you have to find the z naught. If you like, I just explain again. So you want to find the what? You find the z naught such that now you can know what does it mean. Probability that z to be less than z naught, it doesn't matter, less than equal to. You want this one to be 90%. Okay, you want 90%, you know the 9% would be 0.9 to get this number. Now, you have two choices. If you want to use the table, you see, go to that table, back to that table. Remember, the first column is the z number. These are going to be what? Area to the left of the z, or the percentage. So you already got that area to the left is 90% or 0.9. So what you have to do is you have to look for the 90% among these percentage. 90% or 0.9. The numbers start from the smaller one, go to the bigger one. You see the last number that we got over is 0.5 is a negative, so you have to go to the positive. So just check to see where for the first time you will see something like 0.9 or 0.90. Look at these numbers. And these are all 888. So the first time that you see 0.9 is here. You see 0.9032. This is close to the 90%, but try to see if you can pick something closer. Okay, 0.90. And just go back to see, you see, look at here. So here you have 0.9015. 0.9015 is not bad. Okay, it's not bad. It's close to the 90%. But even if you pick this number, look at this number, is a 0.8997. If you run that gives you exactly 90%. So the one that you are looking for, this is going to be your, this is where you are going to get the 90%. So read this number, find the corresponding Z values. What is going to be the corresponding Z values? You see, you have 1.2. 1.2 what? 1.2, 1.28. You see, this is 08. So from this table, okay, it's all right if if you miss this one and you pick the second one and the third one, the number is going to be very close. We don't mind. But I just picked the best one. So the best one is going to be, so if you pick Z or the Z naught to be 1.28, the probability of, you see, that's going to be the case. Going back here. So you are interested for one Z numbers, this area would be 90%. So that number, as we talk about it, the Z naught is equal to the 1.28. 1.28, 29, even 1.3, that give you the one. But I try to pick the one that's going to be much closer to the numbers. Any question? I'll show you with the calculator that you can do it right away. But even with the calculator, you have to get the graph. You have to get it to that area to the left to be able to do it. Okay, so that would be Z 1.20. Of course, you are not done because the actual number must be given in X. Remember, when we do the direct problem, we have the X, we get to the Z score with that formula, and then we find the probability. So now we find the probability, now we have the Z. So in order to get the X, you have a little bit of algebra to do to get the X. Okay, so this is going to be your Z number. So the situation is the X. Okay, so what is X or X naught in this case? Okay, so the Z formula, remember Z is equal to the X minus mu over sigma. X minus or Z. Now the Z number is going to be 1.28, and the X is missing. The mu is what? The mu is 200, and the sigma of 20. Both of them was given to you. A little bit of algebra, cross multiply. You see, think about this one as 1.28 over 1. If you cross multiply, so that gives X minus 200 is equal to the 20 times 1.28. 1.28. So you multiply, then you add the 200. So this would be 25.6. Okay, so your X would be 200. 200 plus 24, 25.6. So that gives you something like 225.6. It's a score, you can call it 226. So the X is going to be 226. So you must score the minimum score, 226, to be accepted for that program. It's quite interesting application of the normal distribution, and you get quite a lot in everyday life. I'll give another one in a minute. Any question? The trick is this one. I give this one several times, so similar one on the test, because we give you one. And most of the people, they pick the 10%, which is not correct. You see the 10% is there because you are going to use the table. So your table give you the area to the left only. Okay, that's why you have to graph it carefully to see which one is it. Sometimes it's going to be just the area to the left that's given to you. Okay, any question? Now let's do it with the calculator. If you go back to your calculator, You see, it doesn't matter the TI or this one, both of them are going to be the same. You see, if you go back to the calculator and you go to that distribution again, when you go to the distribution, you see the one that we used was normal CDF. Now look at the number 3, INV, inverse, invert. Okay, invert norm, inverse of the normal. This operation that we do, this inverse operation, if you like. Okay, so for this problem, you go to the invert. So if you click, you see this. So you have, you can see 3 numbers that you got over here. That should give me the mu and the x. This calculator is not give me the number that I like correctly. I have to go back to this, the other one maybe. Okay, let's try it again. So that would be inverse. I click on the inverse. Yes, that's that. Now you can see it. Look at this one. The first part is area. Area is that percentage that you have. The second one is the mean and the sigma. The area, you must make sure that you give the area to the left. You cannot do the 10% here. Okay, so you have to do the 90%. Okay, so you have to get it to this part, you see, to find out which area you are going to use. So the area would be 90%, so that's going to be the 9. Okay, the one that we use for the table. And the mean in this case was 200. So that's a mean of the 200. And the standard deviation of 20. So we go to standard deviation of the 20. Okay, go to the paste. And then we paste it for us. That's it. Now click again. So that give it the number. You see, this is the X number directly. 225.63. 225.63. Look at this one. We have 225.6 for the X. The advantage is, you know, the X numbers would be given to you right away. You know, it's very good if you have that calculator to get it. But if you don't have it, you know, we can just check as I did. That's very nice operation. Okay, so the only thing is you have to make it. You see, you can use only the area to the left with the calculator here. If you go with the 10%, at 10%, your result would be quite different. So graph it to make sure that the number is the area to the left. Any question? So for this problem, if you like, you have to go to the inverse. You have quite a lot in your book, in your assignments. They don't talk about this business that I gave you. You have one, but they give you just the exact number. They say find the Z numbers or the X numbers correspond to the right of the 10%, 50%, 60%. You can do it using the formulas that I did, or you know, if you would like to use your calculator, we don't mind. Okay, so with this one, that give you the actual X. You know, you get the numbers. It's very nice. Okay, any question? So I should give you another one so that you will see the difference when we pick the area to the light one. And that was, the indication was nicely given to you. We see they said directly top 10%. But in everyday life problem, you don't have this. You have to decide it yourself, okay? So be aware of that one. Any question? So let's get something from everyday life. We can do the Pizza Hut, or we can do the Best Buy. Okay, once, you know, I was just teaching at Palomar. There was an oil change. I need to have an oil change, so I did have time. So I went to the guy. I said, you know, can you do this one quickly for me? He said, yes, I can do it in 30 minutes. I said, I believe you. He said, I do not. How do you know? I said, I teach this one. I can prove it for you. That's exactly normal distribution. Let me have it. Okay, let me give it this one a test. So let's get something from everyday life to see. We can do the oil change type, or we can do the printer one. Okay, let's do the oil change. Okay, that would be different. Okay, so this is going to be the example that we are going to have. Then we give the one with the Best Buy as well. Okay, so this is going to be now. They have to explain it, but it's just bring something which is more the same thing. Yeah, the one that we would like to get is, I think that I want to give you a case which is different. So I go with the Best Buy first. Okay, that's the case which is different. Then I do the Pizza Hut. So this is going to be the case. You see, we know that we talk about the computer printers, HP printers. There's going to be a lifetime for these devices. Okay, and they usually give you this lifetime as a warranty. Okay, there you are. It's known that a computer HP printer, HP printers lifetime, okay, the number of the years, lifetime, follow a normal distribution, follows the normal distribution, of course they should give it the mean, with the mean of 4 years. Okay, mean of 4 years and standard deviation and standard deviation, a standard deviation of 0.78 years. Okay, so that's the official information that we have for this case. Okay, what's the problem? The problem is the number of the time that they are going to register or put as a warranty for the guarantee for the item. Okay, so the company, you see, when they set that time, they want to make sure that if they want to replace the device, the number that they're going to do, they're going to be kind of a minimum one. So the company, they should decide how much they are prepared, to pay. The company will replace. The company will replace any printer that fails. Any printer that fails during the guarantee or warranty time. During the guarantee period. But they want to know how long they should do it. So the question is going to be how long? Okay, how long should the printers? How long should the printers be guaranteed? Guaranteed if the company, okay, of course they want to do it kind of minimum number of the printers to replace. If the company wishes to replace no more than 10%. No more than 10% of the printers. So this is how much, how many they can afford, if you like, or they are ready to replace for us. Okay, again, you have to get a curve to identify, translate your problem into the Z curve, if you like, because it's a normal distribution. Then decide, because this 10% again is going to be probability, but you've got to be careful to see, are you going to use the 10% or the complement of the 10%? Okay, are you ready? So let's check the information that we have. So we know that it's going to be normal case. Okay, it's a normal distribution. It is a normal distribution. I mean, the X is going to be the number of the years. Normal distribution with, because you need those two numbers, you need to identify the mean. The mean is given to is 4 years. So the mu is equal to the 4. Okay, and the standard deviation of 0.78. So we have this information. So we have again a normal distribution case. So let's get the normal distribution. That's going to be normal distribution. Okay. So let's see how we're going to identify that the problem. The problem is going to be the time that we are going to warranty the number of the years. You see, if you warranty, for example, if this is going to be the number of the years that you're going to do it, 4 years, 3 years, 5 years. So we're going to call it the X0. Okay. So this is going to be the time for the guarantee one. So the company would replace only 10% of the printers during that period. So think about it. Where is the 10%? This is 2 years warranty. Is the 10% is the area to the right, or it is going to be the area to the left? Let's explain it. Suppose the warranty is 4 years. If the warranty is 4 years, okay, then the company will replace the item. Is it before the 4 years or after the 4 years? If you buy a cell phone, for example. Yes, Kali, you're right, before the 4 years, yes. You see, that's what will happen. If they said 4 years and something happened to your item tomorrow, you go and you replace it. But if it took 5 years that something happened to your item, after 5 years, you cannot go back and reclaim it. So this is, if this is going to be the guarantee period, anything happened during this time, they are responsible. But if it's anything happened here, they are not responsible. So this would be the punishment area for the company. But of course, the punishment, they want it to be as small as possible, 10% only. Okay, when you set up this curve, the other problem, they basically tell you drop 10%, but you have to decide yourself over here. So just think about it. If this is going to be the time that you set up, of course, if anything happened up to this time, you are responsible. You have to replace it. But you would like this area to be as small as possible. So you want it to be 10%. So quickly, this 10% of the area to the left. So what you have to find this time is you have to find x naught such that, that give you better understanding to write it down. Probability of x to less than x naught to be equal to the 10%. See, that would be your problem to find that x. So the area in question is 10% now. If you change it to the z, so you want to find the z number so that the area to the left of the z to be 10%. You know that the 10% is 0.1. So go back to the table and find the z number that give you the area of the 10% or the 0.1. Okay, any question? Are you ready? Going to the table. So this is the table. So you have the 10% here. You want to find the Z number. 10% start with the 0.1, so pick the numbers that start with the 0.1. Okay, 0.1, 10%, it's very a small number. So the numbers start from the top. These are for the positive, start with the 0.5, end up with the 0.9. So you cannot have it for the positive numbers. So you have to go to the negative part to see if you can see anything that start with the 0.1. You see here, this is like 0.11. Okay, just go on to see if you get something smaller. Okay, because you need something like 0.10. Okay, so if you go here, it's going to be 0.131, 0.11. Okay, that is 0.11. Oh, that's better. 0.1093. But you get a better one here. 0.107, 0.105. Okay, 0.103. And then you get a 0.12. Oh, you get the best one here. So to get this one is the 0.1003. That's exactly what you are looking for. Because if you round that, that would be 10%. Okay, a little bit up and down would be fine with us. Okay, but you just, that give you the hint when you start with the 0.1, but just go on because you are interested in the 10% only. So the 10% would be 0.100 here, and you read this Z number. Okay, what is this Z number? This Z number is going to be negative 1.2. 1.2, you see 0, 1, 2, 3, 4, 5, 6, 7, 8. So negative 1.28. You see, this is 0.8. So negative, okay, so the number is going to be negative 1.28. That give you the numbers. Okay, so what I did, I just explained it here again for you. You see, that was a negative 1.2 that I start. I just keep going to get to the smaller one. So that give me negative. That give you 0.003 that I pick. So if you compare it with the top, so that give you 0.8. So the Z number is going to be, your Z naught is negative 1.28 for this problem. Any question? So make sure don't miss the ABR. You see the other one, the 10% was to the right. We cannot do it to the right from the table. We can only do it when it's left. So that's why we consider the 90%. But over here is already 10%. It's already 10%, so you have to use 10%. Okay, question? But of course you have to get the X. Okay, you have to find the X. So that is going to be the number that we're very interested in. So we go to the Z score formula again, Z equal to the X minus mu over sigma. Okay, so the Z is negative 1.28 and equal to the X is missing. The mu is 4 and the sigma is 0.78. You have to cross multiply. Okay, if you do the cross multiplication, so that gives you X minus 4, which is going to be equal to the negative 1.28. Okay, times that by 0.78. Just use your calculator to simplify this number. If you use your calculator, you can check it, but I have 0.9984. Then you have to move the 4 to the other side. So X would be 4 minus 0.9984. And it's almost 1. So it's going to be almost 3. You have to run that to the nearest whole numbers. Okay, so it's going to be almost 3 years. So the company should set up the warranty time for the 3 years if they don't want to lose, lots of money or much more money. Okay, any question? So your calculator, of course, as soon as you identify that, you have to identify that 10% for yourself first. Because if you want to use calculator, you have to get this one to make sure that you're using the area to the left. Okay, so you go back to your calculator if you want to do it. That is going to be the second, and I turn it on first. So that's on second distribution. We need the normal, the inverse normal, number 3. Okay, inverse normal, number 3. So that's it. So the area you are looking for is 10% this time. Okay, so that's going to be 10%, 0.1. So the area is going to be 0.1. Then the mu is different. In this case, the mean is 4. Okay, the mean is 4. Your standard deviation is 0.78. 0.78. Sorry, that's a 0.78. So we have to paste it. It's the information that we have. That's it. This is your x right away. It's 3.0003, and we call it x equal to 3 years to get the numbers right away. Okay, and that's going to be the same thing here. So we can use the calculator if you like, but as I told you, you have to graph it, just show that you understand the problem, how you relate the problem. Don't just give me a number, because that's important to see which area is it, that 10%. 10% in this problem is the area to the left. So you make it a situation that we did over there. That was the area to the right, and that is why how we take care of it. Okay, so it's 2 cases, and we put 2 on your next practice quiz. I'm going to check it. You have a couple of them in your book. You have the abstract one in your book. They don't give you there is one story in your book about I think it's about the washing machine. They talk about the washing machine, and it's the same as this one. The replacing time they ask for it, but it's very nice, nice application really. So you enjoyed it to see. The normal distribution is all over the places. Whatever you want to do, you have to go with the normal distribution. Okay, any question? So now you should be able to do that section 6.1, 6.2 for the assignment. I will adjust them again because there is one section more that we are going to drop. Now, I check this edition of your book. There is another concept that we usually cover. We call it binomial approximation. It's dropped from this book. It's quite interesting topics, but what I do, I just stay with the book. I drop that one. I usually teach it. But at the end, if we get time, I may just talk about it, but I'm not going to question you. It's in all of the other statistic book, but in this edition, you don't have it. And the story is that for the binomial distribution, that's a very good thing, really. It's very bad that they drop it, because so far we have 2 types of distribution. Remember, we have the binomial and we have the normal. As we can see, the normal is easier to handle. In the case of the binomial, remember I give you a table. The table ran up to the 20. So what would happen if you have more? If you have the sample size to be 10,000, even if you have a good calculator, you can't do it. So what we can do is we can approximate it. We can approximate the binomial distribution by a normal one. We need a little of calculus to be able to understand it. Not just we are not going to do it, but we estimate it. So at the end of the day, this means in distribution, in a statistic, you have to learn only one distribution, and that's a normal. Okay, everything else you can switch it back to the normal distribution. I can show you that because I teach this one for my other section. They do have it. I can just show you in case you want to know it. Okay, this is the one we call it a normal approximation to the binomial. The situation is going to be when the sample n is a large sample, you can't do it. it must have two conditions, NP bigger than 5, NQ bigger than 5 to be able to do it. If the sample is, if N is large, you see these are these histograms are the binomial. Then we can cover it by a bell-shaped type. So we get to the normal distribution. Mu would be N times P from the binomial and the square root of NPQ. And then when we get to the normal distribution, we just nicely using the, okay, this in curves and just talk about it. But if it's good time, we come back and talk about it. I'll give you a break. Then there is something else that the statisticians are very proud of that. And then they call it Central Limit Theorem. It's like in calculus or other topics, we usually have a great theorem, a fundamental theorem. Now, the next idea is interesting because this is the way we are going to do for the rest of the course. You see, for the normal distribution, when the situation is given to you, usually pick one person out and we ask the question. Okay, we pick one person out, we check to see if what is the chance that the salary of that person is going to be less than $100,000. Okay, we pick one person out and check to see if what is the probability that the weight of that person is less than 200 pounds. So what we're going to do, we are going to go into the group. Give it 10 minutes, we come back, and then we discuss that one. It's a great idea, and we finish it before your next quiz. See you in 10 minutes. Oops. Okay, I checked this edition of your book in section 6.6. They talk about the normal approximations, but they give you a note. The note is, they said, since today everybody using technology, so they don't care about that approximation. That's why they just give you a reference, if you want to do it. So we are not going to do it for the time being. Okay. Okay. So let's get back to the this for the rest of this chapter. There is this important section or the concept that we're going to talk about it. So this is going to be a combination of 6.3 and 6.4, and then we finish it. You're not going to cover anything else from this. This section. So what is going to be the idea? The idea is going to be, they call it a distribution of a sample mean. We're going to introduce a new distribution, new function, if you like. Probability function is going to be distribution of the sample mean or means. Okay, and there are different ways to express this one. Sampling of a distribution of a sample means are going to be the same thing. Okay, distribution of a sample means, if you like. Now, what's going to be the idea that we're going to have? You see, so far we pick a variable x about your salary, your weight, your height, and we find out that this x is going to be normal distributed. So we introduce a probability formula, p of x, and then we take care of the problems. We pick one person out, and we check to see if the probability that that person is going to be less than, 200 pounds, a salary of bigger than $200,000, etc. Next thing that we're going to do, we are going to go to a group of people. Instead of investigating these problems about one person, we are going to investigate the same characteristics in a group of the people. You see, suppose you are going to be in a group of the 10 of your friends. Okay, so we are a group of person. Now, if you want to talk about the characteristic of this group, if we talk about the average height, we are going to say what's going to be the average weight of the group of the sample that we have. What is going to be the average salary of that group? So instead of x, which is the variable referred to the characteristic of one person, we are going to pick some samples, sub-collection of your group. And then when we get to the sample, you have various choices. If you have 10 people, and I would like to pick 2 out of these 10 people, so I have many possibilities. So when I pick 2%, then I find the mean of whatever it is of those 2%. So I pick a sample, all the possible samples of 2 people from your group. And anytime I pick 2%, I find, for example, the mean salaries, the mean heights, etc. So the original variable was x. Now I'm going to introduce the new variables. That variable is going to be sample mean. We call it x bar. So we want to compare these type of distributions, the probability of these groups with the original one that we are going to talk about, okay? So it takes time a little bit to introduce it, but at the end of the day, nothing new really. We are going to have a specific normal distribution and we do the job. But for the rest of the course, you are going to be in that group. We are not going to talk about the individual person, if you like, okay? Let me just try to explain that problem for you. Just if you have any question, when we go, just let me know. We are going to set up that. If I give you the formula right away, you are not going to understand it. So we want to do it practically, but don't worry. When we get to the problems, it's short. So let's start with the variable, okay? So for a variable x, that will stand for something which is normally distributed. For a variable x and the given. And a given and a given sample size n. This n is going to be fixed through the argument. Okay, for a variable x and a given sample size n, the distribution, probability distribution, the distribution of the variable, new variable, of the variable x bar. X bar stands for the mean. That is the distribution. The distribution of all possible sample, all possible sample means of samples of size n. Sample of size n. As I talk about, if I want to pick five people from the group, from your class, I have many possibilities. So anytime I pick 5, I find their mean. Then I go to the next group of the 5 people, I find their mean. The next group, I find their mean. So originally I had x, now I have a new variable. That variable is mean, x bar. That's why we call this one distribution of a sample means. So this is going to be of a sample n. So this new distribution is going to be denoted. Okay, it is denoted by P of x bar. Your variable, your function is P, probability, but the variable is x bar. And it's going to be called different name. Okay, it's called, this is called what? This is the expression of your book. The sampling distribution, distribution of sample means, of the sample means. Shortly, we say distribution of a sample means. Means we pick various sample and we find their means. Okay, then again, therefore, this new function, P of x bar, is obtained. How we're going to do it? Is obtained by using the means computed. Okay, means computing from random sample. Random samples of size n. All the possible taken from the population. Taken from a population. From the class. Okay. So for the last time, you see, this is what we have originally. Remember, that was x, that was px. In this case, there was a mean. Mu is the mean. And in this case, sigma is what? Is a standard deviation. A standard deviation. So what are we going to do? We're going to get a new one. In order to get the new one, we are going to pick a number n, and we pick all the possible samples. Okay, so we pick all possible samples, all possible samples of size n. Okay, a size n, Anytime we pick those sample, we find their mean X bar and then their probability P of X bar. Okay, we pick a sample of 5 people, find their salaries, the mean salary, put it here. You pick another 5 people, find their mean. Another 5 people, find their mean. All the possibilities. So in this case, so this is going to be again a probability distribution. So the question is, what is the mean of this new one? So the question is, what is the mean? We call it mu of X bar. Means you are in the new one. Okay, so the question is going to be, what is this mean? Okay, and the question is going to be, what is this sigma, the standard deviation? Is there any relationship between this new one and the, okay, and the old one? Okay, why we are interested in? We are interested in because the problem that we did so far, so we have the probability, remember, we have the probability, we have the mean, and we have the sigma. Then we'll be able to answer the problems. Now we are going to have the similar one, but you are going to have P of X bar. So you are going to have the mu of X bar, and you are going to have a sigma of X bar. Especially if the first one was normal, remember, it was very easy to find these ideas that we are going to have. So that is the situation that we're going to have with this new one, probability of X bar. Remember at the beginning of we talk about what is the probability of P of X to be less than 5. In the case of normal distribution, you pick only 1%. Your sample is just single sample. But in this case, you have the sample of 10 people. So what is the probability that the mean is going to be less than 5? Okay, so we answer simple questions, and the way we go from one to the other one is going to be quite interesting for us. Okay, any question? Now, what I would like to do is, you don't have this example in your book, but I'm going to give you one. What I would like to do, I would like to give you one practical example to see it. Then I give you a relationship between these. There is a formula. We write the formula, that, we substitute, and we're done. We don't need anything new because the probability would be just a Z. Again, Z is called the formula, we're done. But let's do it practically, okay? Let's form one of them. And then in that, you are going to have some conclusion. Then I come back and give you the formula and be done. Okay, so let's pick one sample and just give in this new distribution to see what's going to be a relationship between the original mean and the new mean. Original standard deviation and the new one. Is there any relationship between these two? Yes, there's going to be one. This interaction or relation between these two is the one that the statisticians are very proud of. And they call it Central Limit Theorem in a statistic. I'll tell you what is that Central Limit Theorem is. Okay, but nothing to worry about. At the end of the day, it's going to be just one easy problem. And we answer it. Okay, so let's do this one practically. The conclusion would be something that we needed. And you are not going to have this type of problems for the test, but we know we're just working to understand the concept rather than just having a problem on the test. There you are. This is what I would like to do. I would like to consider a population of 5 starting players in the basketball team. Okay, and from these 5 players, I'm going to pick a sample of 2 players to give you the problem, describe the problem. Consider the population. Consider the population of the 5. Okay, population of the 5 starting players. Players on a men's basketball team. Men's basketball team I'm going to call them, let's give them a name, namely, suppose their names are A, B, C, D, and E. It's going to be their name. The variables that are going to be interesting is going to be their height in inches. Okay, so suppose the variable X that the variable of our interest, the variable of interest, okay, of interest is going to be X. X is what? Is height. It's going to be height in inches, So this is the information that we have. Okay. So suppose this is players, and this is going to be height. Okay, for example, the player A is 76 inches. The player B is 78 inches. And the player C is 79 inches. And the player D is going to be 81. And the player E is what? Is 86 inches. Okay, that's going to be the one. So the X is these numbers. 76, 78, 79, 81, 86. These are going to be the number for the X's. So what's the question? Question is, I'm going to pick sample of these, okay? The sample that I pick, and my sample size is going to be 2. So I want to pick all the possible group of the 2 players from these. And anytime I pick the 2, I'm going to find the mean of their heights, okay? So I get this. So it's going to be your job. The first part, I'd like you to just do it for us, okay? So we'd like to obtain the distribution, of the sample mean, of the sample mean. Of course, that would be P of X bar. Okay, for samples of size n equal to 2. How many samples that you get? Okay, you get those samples and find the mean. That would be step 1. I'm going to do it, but let's give you all the information that we need. Step 2, I would like to go to the original one and find the mean and standard deviation, okay, of the P of X. So find, it's easy to find because I have all the X's here. So find the population, mean, mu, and the standard deviation, and the standard deviation, okay, sigma. Okay, so it's easy to find. I can find it quickly. Then what I'd like to do is you go back to this new one, and do the same thing for this. So would like you to find the population, find the population mean, this time mu of X bar, okay, for the P of X bar, and the standard deviation, and the standard deviation, okay, standard deviation sigma X bar. of what? Of the distribution of a sample mean. Of the distribution of the sample mean of the sample mean P of X bar. Okay, A, B, C, and then, then we are going to see we observe what is going to be a relationship between these. I want you to be surprised, so I'm not going to give you that. Okay, so that's going to be the question. So practically we want to do it. We find that that distribution for ourselves. Okay, are you ready? I need more space, so I go to the next page to be able to do it. So you have the idea now, 5 layers, A, B, C, D, and their heights. So step 1, you are going to find what is going to be all the possible choices for 2 players out of the 10. Okay, so this is going to be how we're going to do it. Solution. So this would be the solution for part 1. Just constructing this one. So make sure you have enough space. Okay, this is it. So in this part, I'm going to pick the sample of the, 2 players. Remember the sample size, my sample size is equal to 2. So these are going to be sample of size 2. For this sample, they are going to have, I'm going to consider their height. Their height is going to be my X. Okay, then for each group, I'm going to find their mean of the group. So this is going to be sample mean, or means of the, okay, it's going to be sample mean of these, okay, or sample means for various group that I'm going to have. Okay, are you ready? Remember, we have 5 players, A, B, C, D. I want to pick all the possible 2 players out of the 5. So the easiest way to do it, you see the 2 out of 5, AB, AC, AD, AE. Then I come back, BC, BD, BE, CD, CE, DE. Okay, AB and the BA considered to be 1, of course, So these are all the possibility that I have. So my first choice is going to be A and B. Their height, I check their height, is going to be 76 and 78. Then I find the average of this height. So I'm going to find what is 76 plus 78 divided by 2. I simplified that, it be 77. So that's going to be the mean of the first sample. Any question? Continue, get all choices, A and C. So the number is going to be 76 and 79. You find the mean, it's going to be 77.5. Then continue, A and D. Find the sample, 76, 81. So you find the sample mean, that gives you 78.5. Then the next choice is going to be AE. A is 76, 86. You find the sample mean of the 81. So that's going to be for the A. Then we go on, we get the B, B, C, B and C. It's a 76, 79. You add divided by 2, that gives you a 78.5. Then we continue, that was a B, C, then we get a B and D. I just want to show you that, you are going to have various choices. So BD, 78, 81. And if you add these numbers together, that give you divided by 2, 79 point, 0.5. And then we continue, we get a B and E. B, E. The number is 7886. You divide by, you find the average, 82. Okay, so we continue, we get the C. You have C and, okay, C and D. So that's going to be 7981. Okay, if you add them together, that give you 80. Then we have the C and the E. C and the E, that give you 7986. And if you added that, give you 82.5. The last one's going to be D and E. D and E, that's going to be 8186. And if you get this number, it's going to be 83.5. So these are going to be all the possible cases that we're going to have. What's that? BC. BC. BC, I have a 76, a 79, but BC. B, oh yeah, 78 and, no, that, yeah, that's 78. BC, that's 78. 78, 79. I think that number may be correct to get these, the value. Okay, thank you. Okay, as you can see, this is a very small sample, but we have 10 choices. Even in some people, they consider this is A and the B, they consider also B and A. Okay, you don't need it, you know. So these are going to be all the possible that we have 10. It must be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10, 10 choices over here. You see, so if you consider these x's all together, that would be your P of x, the distribution that we have. But for the new one, the variable is x bar. So the possible values for x bar is going to be the following that we're going to have. Okay, so that would be step 1. We just organize it. Any question? Step 2, we want to find their means. Okay, so go to the step 2. Step 2 is original population. What is the mean of the original population? And what's going to be the sigma of the original one? Original one, we have only 5 numbers. Remember, that's the case that we're going to have. So we find the mean. It's easy to find the mean. So the mu is going to be, remember originally the sample size is equal to the 5, the original one. So we are going to add them. It's going to be sigma x, if you like, divided by n. So those 5 numbers, or the players. So we have the 76, 78, 79, okay, 81 and 86 divided by 5. If you divide it, that gives you 80 inches. So for the original population, the mean is 80 inches. Any question? Originally, we have only 5 numbers on the heights. Now we have to find the sigma, standard deviations, various formula. We don't need it, but just give you one in case you want to find it. I just use this formula to find it. So the sigma is, I just do the square root of the sigma of x minus mu squared over n. It's the one that we did have. So the result is going to be in this form. Okay, you got the 80, you have to find the differences and you square it. So it's going to be 76 minus 80 squared. Then you do the same thing for the other numbers, 78 minus 80 squared. And you pick all the numbers, all the 5 numbers. So that gives 86 minus 80 all squared. But you divide it by what? You divide it by 5. If you do the difference and just add them together, so the difference and you square it, it's going to be 16 4. Okay, so this is going to be it's going to be 16, 4, and the other numbers. The last one would be 30, 36. Okay, that give you that 5 numbers. So that was, this is a 79, that give you 1. Okay, this would be 1. Then we get the 36. It's going to be the, I just missed one of them, and the 4. You get the 4 here. You see that would be 16, 4, 1, and 1. You get 2 1s. You divide it by the total, which is 5. So basically, it's going to be a square root of 58 over 5. It's going to be 3.41 inches. So that would be sigma is 3.41. Okay, all these numbers, when you do the problem, would be given to you, but I just wanted to find it just to show you what would happen, what is the relationship, so that you believe it. Okay, any question? So that's the second part. We find the mean and the standard deviation for the original sample. So what we're going to do, we're going to do the same thing for the X bar. Okay, in the new one, in the P of X bar. So in order to get the average, you have to add all these numbers together, at this time divided by 10. Okay, so let's find out, see what's going to be the surprise. Surprise is going to be, so we go to the part C, and we are going to find the mu for the new one, X bar, and what's going to be the sigma for the X bar. Okay, that would be the surprise part. The surprise part is for the mu of X bar, you have to add those 10 numbers that we got. So look at this one. If you want to find the mu of X bar, you add those numbers that you got for the X bar, 77, 77.5, and 78.5. Okay, 81, etc. We get to the last one, which is 83.5. But this time you have to divide by 10. If you just add these numbers using your calculator, that give you 800. So the mu of X bar would be 800 divided by 10, which is 80. That's a surprise. You see, mu of X bar is equal to the 80. If you remember, the mu was also 80. So this means the mean of the new distribution and the original one are going to be the same thing. So you don't have to find it. Always the original one would be given to you, so automatically you have the second one as well. So that's one I was looking for. So note that mu was also equal to the 80. So we get to this conclusion that when we go from the original sample to the new one, new distribution, their means are going to be the same. So we can assume this one all the time, and you don't have to find it. Any question? So that's why they like it. This means the mean of the means. This is the way they talk about it. It means the mean of the means. You see, the mean of the means is the mean. It's the same thing that you're going to have. It's a great theorem in calculus. You just do it for 5, 6 numbers. In calculus, we have special sequences. We do it for the infinity many numbers. The result is going to be a sequence that we call a Caesarean sequence. You know, if you're going to be a math major, those Caesarean sequence, quite interesting one. It's used in science to get the estimation. You know, if you do something in physics or engineering, it's going to be quite a lot around. But this is just a finite number you have it. Okay, so that would be so that you believe it from now on when I write it down. The standard deviation is a little bit different. The standard deviation of the mu of X bar, just using the same formula, you see that give you X bar minus the sigma of X bar minus mu all squared divided by n. But I just write a couple of numbers so that you know what's going on. Again, you don't have to do it, but just to confirm, 7 is 8, you need minus, you have to get subtract. You have to find the difference of 10 numbers this time. Okay, again, it can be done by calculator. 3.5 minus 80 all squared. Now you divide it by 10. Okay, if you simplify this one with your calculator, that gives something like this, square root of 4.35, which is 2.09. So sigma xs bar is going to be 2.09. But so this is different for the standard deviation that we have originally. Okay, so note that original one was something like 3.4, and so sigma of x bar is not equal to the sigma. It's going to be different. In general, their difference is, the relationship is this: sigma of x bar is equal to the sigma divided by the square root of n. Remember, n is the sample size. N is the sample size that you pick, and that's the standard deviation of original one. N is going to be is the sample size. So the conclusion of this example is going to be this one, that we're going to take, we use it all the time without any proof. The conclusion is that mu of x bar is the same as the mu. So you don't have to worry about it. You can use it anytime you like. But a standard deviation is different. It's sigma over radical n. So if you want to create a formula for P of x bar, which is going to be, which is going to be, corresponds to the, to the original one, this is the way you are going to know. We are going to do it. Okay. Any question? Now let's see what we have and what we are going to do. So the situation is going to be, you see, give you a remark, then I'll finish it the next time. But this is going to be the way we are going to do it. You see, look at this remark. Because the question is going to be how we're going to use it for the probability. So the remark is going to be, you see, if the original variable, if x is normal, is normally, okay, it's going to be normal, x is going to be normally distributed, then remember, in order to do the problem, you need a z-score. Then z-scores can be computed, using this formula. But to be very careful. The formula is, as we did it before, z equal to x minus mu over sigma. In this case, it's like the sample size n is equal to 1. You see, we usually pick 1% out and we ask you the probability question. So this is going to be if x is going to be normally distributed. Now, if x bar is going to be this new one, if x bar is going to be normally distributed, you have the same question. You have to find the probability again. Then that's the difference. Z-scores can be computed, okay, Z score can be computed using this formula. Look at the formula, Z equal to, your variable is X bar, is not X. So your formula would be X bar minus mu over, you see, the mu is the same as the mu. So I changed the X into the X bar, but I didn't change the mu because they are equal to each other. But remember, the sigma is different. The sigma is sigma over radical n. So that is going to be a difference between the first formula and the second one that we're going to use. Okay, so originally this is going to be your Z score, and we usually pick 1% out. But in this form, n is going to be the sample size. This n over here, n is the sample size. Is the sample size. So in the original one, suppose if n equal to 1, you see the radical one would be 1. Then they usually ask the same question. You see, what is the probability that I pick 1% out from this class and your salary is less than $100,000? That's the first part. The second part is, oh, now I'm going to pick 5% from this class. What is the probability that their mean salary is going to be less than $100,000? So in that case, I switch the formula and just use the Z score that give me the one right away. Okay, so we set up the problem, but that theorem, I'm going to talk about it on Thursday to finish it. And that would be the one that they call it normal distribution, and they call it Central Theorem, and they are very proud is that if X is normal, this X bar would be also normal automatically. So we can use the Z score. But the one that they are going to, if this X is not going to be normal, you know that if X is not normal, you cannot use this one. But if the sample size is large in statistics is bigger than 30. So if n is going to be bigger than 30, that's the central theorem. X bar is always normal, regardless of the X. So when n is bigger than or equal to the 30, X bar is normal. So you can use this Z score and do the problem. That's why in the statistics, what they do is, if they have a small sample, they make it larger so that n would be 30 or bigger, so that they be able to use the normal distribution. So that's why you need only normal distribution in a statistics, nothing else, because that's why they call it central theorem. So I'm going to talk about that theorem next time, okay? And just a couple of examples be done. Because the situation is, as soon as you write it down, Z score the table that do the job for us, okay? But you have to modify this Z, even if you want to use your calculator. You have to find the Z in this form and then go and get the calculator or just the table that we have. Okay, so then we finish this chapter 6. We are not going to do anything else. So I check if there's going to be, I've already assigned one of the assignment, okay, and I may do one more from this chapter 6, but you can do 6.1 and 6.2 so far. Okay, just get this one, and then I check. I may drop another one from this chapter and then be done. And this is, we almost be ready for the next quiz. Okay, so that was the building up this idea, but we just have to give you the theorem and a couple of examples, and then we're done with this chapter.